Okay, so have you ever thought about, like, what if there was a way to just kind of, like, unlock some hidden, like, energy reserves in your body
Hmm.
and kind of simplify how you think about food and eating without having to go on, like, some crazy restrictive diet
Yeah.
or count every single calorie?
That'd be
Right,
amazing.
what
Right.
if your body kind of already knew how to do that? It
Yeah.
just had this ability built in.
Well, I mean, our bodies really are pretty incredible when you
Yeah.
think about it, like how adaptable they are, and
Yeah.
you know, a lot of people are exploring this,
Yeah.
and it really does work with our biology
Yeah.
instead of against it.
Yeah.
It's a way of eating that focuses on like when you eat
Right.
rather than what you eat,
Mm.
and it can have some pretty big effects.
So welcome to the deep dive where we take like a ton of information and we
Yeah.
try to like boil it down to the core insights
Right.
so that you can actually use them
Minimize them.
quickly and
Right.
clearly. Today we are diving into the world of intermittent fasting.
Yes.
We have a really comprehensive set of slides here
It's fascinating.
that lay out the detail.
Yeah.
And we want to make sure that by the end of this deep dive, you really understand how this works and
Right.
why it's become so popular
Absolutely.
as a health strategy.
It's really easy to get overwhelmed with all the information that's out there.
Right.
So we're going to help you navigate that
Yeah.
and really understand what the science says
Okay.
based on the material that we have.
Now, before we jump into that,
Right?
huge thanks to London Heartbeats Academy in the UK.
Yes.
They have been providing just ongoing, amazing educational support.
They're fantastic.
And for you, our listener,
Yeah.
if you're looking to expand your knowledge, they have an incredible catalog,
Right.
over 150 popular courses.
Wow.
So definitely worth checking out. And if you want to make sure that you don't miss out on future amazing discussions like this one, be sure to follow them on Facebook, Instagram, and YouTube.
Yeah.
They provide free, regular updates there.
I'll do.
Okay,
It's great.
so let's get to it.
All right.
Our mission today is to explore intermittent fasting in detail.
Yeah.
We want to know what it is,
Right.
how it works inside your body,
Okay.
what the potential benefits are,
Interesting.
according to the information we have,
Right.
and some important things to consider if you're thinking about trying it out
Well, that's really important.
yourself.
Exactly.
So we're going to break down all the information so you walk away with a
Gladly.
really solid understanding.
Perfect. And there's an interesting image here right away.
Yeah.
A dinner plate with a clock face on it.
Along with a fork and a knife.
I like that.
Right away, this is telling you.
Yeah.
It's not just about what you eat.
Right.
It's about when you eat.
It really captures the core concept of intermittent fasting.
Yeah.
It's not just about constantly restricting calories. It's about when you're actually allowing your body to take in food
Right.
and when you give it a break.
Yeah, okay.
The clock is a really nice touch there.
Yeah.
That's a time-based approach
It
to
is.
sentencing.
So the next section delves into the metabolic switch of cancer cells. It explains that cancer cells have this really unique way of producing energy
Okay.
called anaerobic glycolysis.
Anaerobic glycolysis.
And think of it like they're running on this less efficient engine
Okay.
that doesn't really use a whole lot of oxygen.
Interesting.
And this process is linked to problems with their mitochondria.
Okay.
Those are those like cellular powerhouses that we talk about a lot.
Right.
It's also linked to a lack of oxygen within the tumor itself,
Hypoxia.
hypoxia, and
Yeah.
a really strong dependence on sugar for fuel.
Interesting.
So the strategy outlined here is to cut this metabolic switch.
Okay.
How do you do that?
Yeah. How?
Well, the three key ways are
Okay.
mitochondrial biogenesis,
Right.
hyperbaric oxygen therapy,
Okay.
and crucially,
Yeah.
drastically reducing the sugar supply.
Makes sense.
They even talk about a metabolic approach to cancer and
Mhm.
considering cancer as a metabolic disease.
Like a different way of thinking about it
Yeah,
than what we're used to.
totally.
Yeah.
So it's like this idea that cancer has this vulnerability.
Mm-hmm.
It's addicted to sugar.
Right.
It has inefficient energy production.
Yeah.
So this is a way that maybe we could attack it.
By focusing on those weaknesses, by
Right.
strengthening the healthy cell energy production,
Right.
increase oxygen,
Right.
and get rid of their fuel source, the sugar.
Okay. So hopefully you're disrupting their growth and survival.
Okay, so then right after that,
Yeah.
we get into mitochondrial biogenesis.
Okay. So that's all about improving the health
Yeah.
and function of our mitochondria.
Yes, and the very first point here is diet.
Okay.
And it emphasizes a diet that's high in fats, provides adequate protein,
Okay.
and completely cuts off sugar.
So this is all about providing the fuel
Right.
to our bodies that impacts our cellular health,
Okay.
and especially the mitochondria.
Yeah, and the reason behind this is so interesting
What is it?
because ketone bodies,
Yeah.
which your body produces when it burns fat for energy,
Okay.
are described here as a non-fermentable fuel.
Interesting.
So that's in contrast to sugar,
Right.
which cancer cells can really easily use
Yeah.
to fuel their growth.
So we're starving the cancer cells
That's
and
right.
feeding the healthy cells
Yeah.
with the ketones.
Right.
Yeah.
And the slide also mentions that a low protein intake
Okay.
can help inhibit something called MTOR.
MTO.
MTOR.
Okay.
You can kind of think of MTOR as a signal
Okay.
that promotes cell growth.
Okay.
So this is fascinating
Yeah.
because it's saying that by adjusting how much protein we eat,
Right.
we can actually influence this MTOR signal,
Yeah.
which could then impact things like cancer development.
It is fascinating how much control we actually have
Yeah.
over these things.
Okay. And then it lists a bunch of specific dietary approaches
Okay.
that kind of align with this philosophy.
Yeah.
So things like the ketogenic diet.
Oh, yeah. KD.
Familiar with that one?
Mitochondrial metabolic therapy, or MMT.
MT. Yep.
And the low-carb, high-fat diet regime,
Right. LCHF.
or LCHF.
Yeah.
So these are all kind of variations on this theme
Right.
of shifting our metabolism away from sugar
Yeah.
towards fat.
Got it.
Okay.
Interesting.
So right under diet,
Okay.
the next way to support mitochondrial health that's listed here is intermittent fasting.
Oh, okay.
And it's described as a fat burner, less ROS.
Less ROS.
Okay. Now, ROS stands for reactive oxygen species, which are these unstable molecules
Yeah.
that can damage cells.
Okay.
So essentially, intermittent fasting is being presented here as a way to burn fat,
Okay.
similar to a ketogenic diet,
Right.
but potentially with less of that
Less of that oxidative stress.
oxidative stress.
Yeah.
It's also associated with low-calorie intake
Okay.
and autophagy,
Autophagy.
which is that cellular cleanup process.
We'll get into that. Yeah.
I'll talk about more in a bit.
Yeah.
And right here, we see that familiar image again. A clock,
Right.
clearly indicating periods of fasting.
Yeah. Yeah.
So it's like it's being presented as a dietary strategy
Right.
alongside specific food choices.
Yeah. It's a powerful tool
Right.
that complements these specific dietary approaches
Right.
by creating periods where your body isn't constantly processing food.
Right.
It encourages a shift towards burning stored fat for energy,
Okay.
much like a ketogenic diet does through carbohydrate restriction.
Right.
But the added benefit
Yeah.
of potentially lower ROS production
Right.
makes it a very attractive strategy for overall cellular health.
Yeah.
Right.
Okay, so the next little point for improving mitochondria is to avoid stress.
Avoid stress.
Right?
Sugar.
Sugar.
Obesity.
It briefly mentions a connection between the hypothalamus in your brain,
Right.
which plays a big role in regulating body functions,
So many body functions.
sugar burning mode in the body,
Okay.
and the issues of stress, high sugar intake, and obesity.
So it's suggesting these are all interconnected.
Yeah, like chronic stress and a diet high in sugar
Yeah.
can create this vicious cycle
Right.
where the body becomes reliant on burning sugar for energy.
Right. Okay.
And that can lead to metabolic imbalances and weight gain.
Right.
And the hypothalamus, as like a central control center,
Yeah.
is involved in all of that.
It's complex,
Yeah.
but interesting.
So moving along in how to boost your mitochondria,
Okay.
we have exercise and physical activity.
Right.
The slide highlights that regular endurance exercise
Okay.
promotes something called PGC1 alpha,
DGC1 alpha.
as well as ROS fission
Okay.
and an MTOR-like protein.
Interesting.
And we've got an image here of someone actively working out.
So they're like running.
Yeah, PGC1 alpha
Yeah.
is a key regulator
Okay.
of mitochondrial health.
So exercise
Yeah.
is a really powerful stimulus for mitochondrial growth and function.
Right. And PGC1 alpha is like
Yeah.
the master switch that turns on those genes. Involved in creating new and healthy mitochondria,
Yeah.
and endurance exercise
Right.
is really good at activating this.
So like long runs, things like that.
Right. Okay. Then we have a section called Feeding Your Mitochondria.
Feeding your mitochondria.
This is all about those essential micronutrients.
Right.
The list here includes CoQ10, ubiquinol,
Okay.
L-carnitine,
L-carnitine,
D-ribose,
D-ribose,
magnesium,
omega-3 fatty
you
acids,
got it, B vitamins,
B vitamins, yeah.
specifically riboflavin, thiamine, and B6.
Okay.
alpha-lipoic acid, or ALA,
ALA, yeah.
and thiotacid.
Thiotacid, wow.
And the key message here
Okay, what's that?
is to try to obtain these from unprocessed foods.
Right.
And there's a beautiful picture here of colorful fruits, vegetables, nuts.
Yeah. So it's really about nourishing your mitochondria with the right building blocks and getting them from whole foods.
Right.
Means your body can use them better.
Right. And then finally, in this section on mitochondrial biogenesis, we have a point to avoid environmental toxins.
Avoid environmental toxins, okay.
And it mentions that these toxins can lead to that oxidative stress that we talked about.
Which is not good.
Which is not good for our overall health, including our mitochondria.
Yeah, our modern environment can really expose us to a lot of toxins.
Yeah.
And it can strain our cellular systems.
Right.
Including the mitochondria.
Okay.
So minimizing our exposure to those is important too.
Okay, so next up we have a slide that introduces autophagy.
Autophagy.
And I love this.
What is it?
It describes it as the housekeeper in every cell.
Oh, wow. I like that.
It really paints a picture, doesn't it?
It does.
Of what this process does.
Yeah, it really does. It's like your body's natural system for cleaning out damaged or unnecessary components within our cells.
And right below that, we see a diagram that mentions autophagy, along with AMPK.
AMPK.
And MTOR. Yes. Those are two very important signaling molecules within our cells.
They're like the master regulators that control when this cleanup process happens.
Okay, so the next slide dives into the major health benefits of autophagy.
Okay.
And it explains that fasting, including intermittent fasting and following a low-calorie diet, stimulates autophagy by increasing the activity of AMPK.
AMPK, right.
And decreasing the activity of MTOR.
Oh, MTOR, yeah.
So it's explained that when MTOR is very active, it essentially puts a stop to autophagy.
It does.
Okay.
Interesting.
And interestingly, MTOR is very sensitive to the amount of dietary amino acids that we eat, which are the building blocks of protein.
Right.
So this is really interesting because it suggests that by manipulating our protein intake, we can actually influence this whole process.
Right. We can influence this whole process.
Yeah.
So autophagy is kind of responsible for getting rid of the defective and damaged cell parts. It's like our cells performing their own internal spring cleaning.
I love that.
Don't you?
Yeah.
Yeah, and when your energy levels are lower, like during periods of fasting or calorie restriction, AMPK gets activated. And it's like a signal to find internal sources of energy and get rid of those damaged components.
Yeah.
And on the other hand, when we're constantly eating a lot of calories, especially protein, MTOR is super active.
Okay.
When MTOR is active, autophagy suppressed.
It's like a seesaw.
It is.
Right.
It is. So that cellular cleanup just isn't happening as well.
Okay. So how do we actually get this cellular housekeeper working effectively?
Yeah.
Well, the next slide is all about practical interventions to promote autophagy. And the very first one listed, perhaps the most accessible for most people, is simply fasting.
Fasting.
Specifically caloric restriction.
Okay.
Which can activate autophagy by influencing 5 different molecular pathways within the cell.
So it's like sending a signal to your cells that they need to be more efficient and resourceful.
Right.
Leading to this cleaning and recycling process.
Okay. The list continues with sunlight.
Sunlight, okay.
Vitamin D and clotho.
And clotho.
And it explains that these can help activate autophagy by inhibiting the insulin IGF-1 pathway.
Okay.
So think of that pathway as another signaling route involved in growth and metabolism.
So it's not just what we eat, but it's other lifestyle factors as well. Like getting enough sunlight and having good vitamin D levels.
Okay.
They can influence this as well.
Yeah. And clotho is a protein involved in aging and metabolism.
Yeah. So interesting how it's all connected.
Yeah.
Yeah.
Next up on the list is rapamycin.
Rapamycin.
And the slide explains that it activates autophagy by inhibiting TRC1 and TORC2 mechanisms.
Okay.
Now, TORC1 and TORC2 are very closely related to that MTOR that we've been talking about.
So rapamycin is a pharmaceutical compound that's known for its ability to inhibit MTOR and therefore induce autophagy.
Okay. We also have caffeine.
Caffeine. Oh, interesting.
And green tea.
Green tea.
Specifically a component in green tea called EGCG.
Right, EGCG.
And it says that both of these activate autophagy via an mTOR-dependent mechanism.
Yeah.
Now, this might seem a little contradictory.
Yeah, because we just talked about how mTOR generally inhibits autophagy.
Right.
So how does that work?
Yeah.
It's almost like these cellular pathways are so complex
right.
and can have different responses to different things.
Right.
So while high levels of mTOR tend to suppress autophagy, certain compounds.
Right.
Like caffeine and EGCG might have like more specific short-term interactions with that mTOR pathway.
Okay.
And they can actually trigger autophagy under certain conditions.
So it's not just a simple on-off switch.
No.
It's more complicated than that.
It is.
Okay, so the list goes on.
It goes on.
Okay, we have metformin.
Metformin.
Which is a common medication.
Right.
And then there's lithium.
Lithium, okay.
Resveratrol.
Resveratrol.
A compound found in red grapes.
Oh, interesting.
Spermidine, a compound found in a bunch of foods.
Spermidine.
Okay. Hypoxia, or low oxygen condition.
Okay.
Phytosubstances.
Phytosubstances.
Activating the NRF2 pathway.
The NRF2 pathway.
Which are found in things like soy products and hot chili peppers.
Hot chili peppers, wow.
So it's this really comprehensive list of things that can potentially boost this cellular cleaning process.
Right. It's like our bodies have multiple ways to activate this essential cellular maintenance program. It really opens up a lot of possibilities.
It does.
For promoting long-term health.
Okay, so now we're shifting gears.
Okay.
We're going to discuss the metabolic syndrome.
Metabolic syndrome.
And it's defined here as the insulin resistance syndrome.
Okay.
It's also known as Syndrome X.
Syndrome X.
Deadly Quartet. And Reven syndrome.
Reven syndrome, okay.
So essentially it's described as this co-occurrence of several well-known risk factors.
Risk factors.
For cardiovascular disease.
Okay.
And these include type 2 diabetes.
Type 2 diabetes.
Okay.
Central obesity.
Central obesity.
Which is that excess fat around the waist.
Got it.
Atherogenic dyslipidemia.
Atherogenic dyslipidemia.
Which basically means unhealthy levels of fats in the blood that contribute to heart disease. And hypertension.
Hypertension.
Or high blood pressure.
Right, so high blood pressure.
And the slide really emphasizes that these aren't just isolated problems. They're interconnected. They are.
They share underlying causes and biological pathways. And there's a really helpful visual here showing how the metabolic syndrome is linked to a tendency towards blood clotting.
Okay.
Unhealthy blood fat levels.
Yeah.
Elevated blood pressure.
Got it.
High fasting blood glucose or blood sugar.
Okay.
A state of chronic inflammation and that abdominal obesity that we talked about.
So it's really a cluster of interconnected health issues.
It is.
Yeah. It's not just a random collection of problems. It's a cluster of metabolic abnormalities that really increase your risk for serious diseases.
Heart disease. Joke.
Type 2 diabetes, and the visual really shows that.
It does. So the next slide gives us a more specific definition.
Good.
The metabolic syndrome definition according to the International Diabetes Federation.
Okay.
And the key criterion here is the presence of abdominal obesity.
Abdominal obesity?
Along with at least 2 other components.
2 other components.
For a list that includes elevated blood pressure, low levels of HDL cholesterol.
The good cholesterol.
The good cholesterol.
Yeah.
Elevated triglycerides. And impaired fasting glucose, which would include someone who has been diagnosed with diabetes. And we see that same interconnected web of risk factors visualized again.
And so they're really emphasizing abdominal obesity as a central feature.
Yes.
All right.
Now we're going deeper into the insulin resistance syndrome.
Okay.
It's described as a state of hyperinsulinemia.
Hyperinsulinemia.
Meaning abnormally high levels of insulin in the blood.
Okay.
And what's referred to as insulin toxicity.
Insulin toxicity.
And the slide then lists a whole bunch of factors that contribute to insulin resistance.
Okay.
And they're broadly categorized as a sedentary lifestyle.
Sedentary lifestyle.
And this includes things like consistently taking in more calories than you burn.
It's a diet that's high in refined carbohydrates and sugar.
Yeah.
Physical inactivity. Chronic stress. Not enough sleep. Being overweight or obese. And even certain medications. And then it outlines just how many consequences can come from insulin resistance.
Oh, wow.
It affects pretty much every system in the body. Direct damage to blood vessels. Problems with blood clotting, high blood pressure. At its core, it's not really a diet in the traditional sense. It's more of an eating pattern, a conscious cycle between periods of eating and voluntary fasting.
So it's less about restricting specific foods and more about strategically choosing when you eat.
Exactly. It's about the timing of your meals, rather than rigidly controlling the content of what you eat.
And it's definitely a topic that's gained a lot of attention lately. Why do you think that is? What's driving this surge in popularity?
Well, a few factors are contributing to it, I think. There's a growing body of scientific evidence supporting the various health benefits associated with intermittent fasting.
That always helps, right? When there's actual research backing up the claims.
Absolutely. And beyond that, it also shows some real promise in addressing certain metabolic issues, particularly things like insulin resistance.
Which is a pretty significant concern these days with rising rates of type 2 diabetes and all.
Right. And another appealing aspect is that some research suggests people find intermittent fasting easier to stick with compared to other, more traditional diet plans.
Ah, that's the key, isn't it? The best diet in the world doesn't do much good if you can't stick with it long term.
Absolutely. Sustainability is crucial for any lifestyle change.
So, to give our listeners a clear roadmap for this deep dive, what are the key areas we're going to be exploring today?
We'll start by breaking down the different methods of intermittent fasting, the common approaches people use. Then we'll get into the science of it all, how IF affects your body at the cellular and hormonal level.
Okay, so really understanding how it works from the inside out.
Exactly. Then we'll discuss its potential benefits, particularly for weight loss and overall well-being. And finally, we'll touch upon some important safety considerations because, as with any significant lifestyle change, there are things to be mindful of.
Makes sense. Safety first, always. So let's jump right in. Can we start with the clear, concise definition of intermittent fasting?
Of course. As we mentioned, it's fundamentally a pattern of eating and planned periods of abstaining from food. And it's important to note that it's not some obscure fringe idea. It's actually quite popular right now within the health and fitness world.
And we talked about some of the reasons for this popularity, right?
Yes, it's gained traction because of the increasing evidence suggesting various health benefits, its potential for managing metabolic issues, and the perception that it's easier to maintain over time compared to more restrictive diets.
Okay, so it's about timing your meals strategically. Now, are there different ways people actually put this into practice?
Definitely. All intermittent fasting methods revolve around dividing your day or week into distinct eating and fasting periods. During fasting, you consume very little to no calories. And it's crucial to remember that you shouldn't try to make up for missed calories during the eating periods by overeating. If weight loss is your goal, controlling your overall calorie intake is essential, no matter which method you choose.
So it's not a free pass to binge eat when you're not fasting.
Exactly. Yeah. Now let's talk about the most common ways people structure their IF routines. One of the most popular and arguably the easiest to adapt to is the 168 method, also known as the Lean Gains protocol. It involves skipping breakfast and restricting your daily eating to an 8-hour window. For example, you might eat between 1 p.m. and 9 p.m. and then fast for the remaining 16 hours.
16 hours sounds like a long time.
It might seem that way, but remember, that includes your sleeping hours.
Okay, that makes it a bit more manageable.
Right. Another popular method is called Eat, Stop, Eat. It involves having 1 or 2 24-hour fasts per week. For example, you might stop eating after dinner one day and not eat again until dinner the next day.
Wow, that's a full day of no food. It sounds a bit more intense.
It is, but some people find it suits their lifestyle. Then there's the 5.2 diet. You eat normally for 5 days a week. And then, on 2 non-consecutive days, you restrict your calories to about 500, 600 for the entire day.
So with the 168, you're focusing on daily time restrictions. With Eat, Stop, Eat, it's full-day fasts. And with 5.2, it's calorie restriction on specific days.
Exactly. But the underlying principle across all methods is intentionally creating periods of eating and fasting.
Okay, now I'm curious about the how. How does this back and forth between eating and fasting actually work within our bodies?
Well, think of it like a seesaw. On one side, we have eating, and on the other, we have fasting. When you eat, your insulin levels go up. This signals your body to store sugar in the liver and also promotes fat production in the liver.
So eating tips the seesaw towards energy storage.
Right. When you fast, the seesaw shifts. Insulin levels drop, and your body starts using stored sugar for energy. And when that runs out, it turns to fat.
So fasting flips the switch to energy utilization?
Precisely. If you were to visualize your insulin levels throughout the day, you'd see spikes after each meal, but a significant drop during a prolonged period without food, like overnight. This extended period of low insulin is what allows your body to tap into fat reserves.
Makes sense. But is that the whole story? Are there other things happening beyond just insulin regulation?
Oh, absolutely. Intermittent fasting affects the body in many fascinating ways. For one, when your body shifts to burning fat for energy, it produces molecules called ketone bodies, or KD. These can act as an alternative energy source and might even be linked to producing fewer harmful molecules called reactive oxygen species, or ROS, which can damage cells.
That sounds a bit like what happens in the keto diet with its focus on fat burning.
There are definitely some parallels. Another factor is simply the overall reduction in calorie intake that often comes with IF. Even if you don't intentionally eat less during your eating windows, the shorter time frame can naturally lead to consuming fewer calories.
So calorie restriction plays a role too, even without consciously trying.
Yes, and this calorie restriction on its own has benefits like potentially increasing metabolic rate and boosting antioxidants in the body. Plus, IF often means not eating for several hours before sleep, which is beneficial for metabolic health.
Right. Now, I've also heard about something called autophagy in relation to IF. Can you explain what that is?
It's like your body's spring cleaning system at a cellular level. When you're not digesting food, your cells use this time to break down and remove damaged parts, including dysfunctional mitochondria, which are the energy powerhouses of cells.
So it's a cellular renewal process.
Precisely, like taking out the trash, making sure everything is running smoothly.
Very cool. And I think I've even seen some research suggesting a potential link between IF and the immune system, maybe even cancer.
There is some early research looking into IF's effect on the immune system, especially in the context of cancer. Some studies have hinted at a possible connection between IF and reduced cancer recurrence and mortality, although much more research is needed to draw firm conclusions.
Fascinating. So we've talked about fat burning, calorie restriction, autophagy, and even the immune system. What about the impact on our cells and hormones?
This is where it gets really interesting. AF has significant effects on several key hormones. For instance, human growth hormone, or HGH, can increase dramatically during fasting periods, sometimes as much as 5 times its normal levels. And HGH is known for its role in fat loss and muscle gain.
A 5-fold increase. That's huge. What other hormonal changes happen?
Insulin, a key player in metabolism, is significantly affected. As we talked about, insulin sensitivity improves and levels drop drastically during fasting. This makes stored body fat more accessible for energy.
Makes sense. So IF makes your body better at using its own fat reserves.
Exactly. And then there's the cellular repair we discussed, autophagy, where the body cleans up old and dysfunctional proteins. Lastly, IF can even alter gene expression, affecting the activity of genes related to longevity and disease protection.
So all these changes in hormones, cell function, gene expression are ultimately responsible for the range of health benefits associated with IF.
Exactly. Now, one of the main reasons people are drawn to IF is weight loss. How effective is it compared to other methods?
That's a good question. We see so many different weight loss approaches out there.
One key factor is that by limiting your eating window, IF often leads to a natural reduction in calorie intake. But it goes beyond that. IF also changes your hormone levels to facilitate weight loss. We talked about reduced insulin and increased growth hormone, but it also increases norepinephrine, which is involved in fat burning. Some studies even suggest a modest increase in metabolic rate, maybe around 3–14%.
So IF seems to be tackling weight loss from both sides, fewer calories in, and potentially more calories burned.
Right, and studies back this up. A 2014 review found that people practicing IF lost an average of 3–8% of their body weight over 3–24 weeks. Plus, they lost an average of 4–7% of their waist circumference, which indicates a reduction in that harmful visceral fat.
Visceral fat, that deep belly fat, is the most dangerous kind, right?
Absolutely. And another interesting point is that some studies suggest IF might cause less muscle loss than traditional calorie restriction diets. But maintaining adequate protein intake and doing strength training are still important for muscle preservation. But let's be clear, the main reason for weight loss success with IF is likely still consuming fewer calories overall.
Okay, so it's a combination of things working together. Now, what about those hormones that control hunger and fullness, leptin and ghrelin? How does IF affect them?
That's a really important part of the picture. Normally, insulin and leptin signal to your brain that you're full, while ghrelin tells you you're hungry. But in obesity, people can develop leptin resistance, where the brain doesn't respond as effectively to the fullness signal.
So the body's natural system for regulating hunger is out of whack.
Exactly. And if ghrelin isn't suppressed properly, you feel hungry more often, leading to more eating and potentially more weight gain. High sugar intake, especially fructose, can mess with this whole system, making you feel even hungrier.
So sugary foods are a double whammy, empty calories, plus they disrupt appetite control.
Right. Now, this is where IF comes in. It may help reset these hunger signals. It potentially reduces hunger pangs by lowering or normalizing ghrelin levels, resulting in a naturally decreased appetite.
That would be a huge help for people who struggle with constant hunger on traditional diets.
Absolutely. And there's another interesting point related to food order. Some research suggests that eating protein before carbs can lead to lower blood sugar levels after meals.
So the sequence in which we eat different nutrients matters too.
It seems so. But moving beyond weight loss, IF has been linked to a wide array of other health benefits.
Yay, we've touched on some of them, but let's get a more complete picture.
Okay, big picture. Intermittent fasting changes how your cells function, how your genes are expressed, and your hormone levels. We talked about lower insulin, higher growth hormone, cellular repair through autophagy, and shifts in gene expression.
And these changes are what lead to all the specific health benefits.
Right. So let's list some of those evidence-based benefits. First, as we've discussed, it can help with weight loss and reducing belly fat.
That's a big one for many people.
Second, it improves insulin sensitivity, lowering the risk of type 2 diabetes. Studies show it can lower blood sugar levels, especially in men.
With type 2 diabetes being such a growing problem, that's a significant benefit.
Absolutely. Third, IES reduces oxidative stress and inflammation in the body, both of which are linked to aging and various diseases.
So it's fighting those processes that contribute to us getting older and sicker.
Exactly. Fourth, it might benefit heart health. Studies show improvements in blood pressure, cholesterol, triglycerides, and inflammatory markers, all risk factors for heart disease.
So positive effects on the cardiovascular system, too.
Yes. Fifth, as we mentioned earlier, it promotes cellular repair processes like autophagy.
That cellular spring cleaning.
Right. Sixth, there's some early research suggesting a possible role in cancer prevention. Most evidence comes from animal studies, but one human study showed it might help reduce chemotherapy side effects.
So maybe a supportive role in cancer treatment.
Potentially. Seventh, it seems to be good for the brain. Studies show IF might increase the growth of new brain cells and protect against brain damage.
Brain health is so important, especially as we age.
Absolutely. Eighth, animal studies suggest it might help prevent Alzheimer's disease.
Another huge concern for many people.
Right. And ninth, considering all these positive effects, IF might even contribute to a longer lifespan.
Wow, that's quite a list. Reduced blood lipids, better blood pressure, less inflammation, less oxidative stress, potential cancer prevention, cellular repair, more fat burning, increased growth hormone, higher metabolic rate, better appetite control, blood sugar control, better cardiovascular function, and even better brain plasticity.
It's a lot to take in, but the research is very promising.
Now, when we talk about weight loss, it's interesting to compare IF to other approaches like bariatric surgery or traditional diets.
It is. We're facing an obesity epidemic and people are desperate for effective solutions.
Where does I fit into the picture?
Well, bariatric surgery can lead to significant weight loss, but it's a major invasive procedure with potential risks and complications. So we need effective dietary interventions that people can stick to long-term without surgery.
So something less drastic, but still effective.
Exactly. And IF seems to fit that bill. It's generally palatable, can be done while meeting nutritional needs, helps with fat loss while often preserving muscle mass, and has a good safety profile. It's also relatively simple to understand and implement, and doesn't require special equipment or constant monitoring.
And I remember reading that some of the benefits seen after bariatric surgery might be due to the fasting that occurs as a result of the altered digestive system.
Yes, some experts believe that many of the positive changes after bariatric surgery could be attributed to the enforced periods of fasting. The surgery limits how much you can eat at once, leading to longer periods between meals.
So it sort of mimics IF in a way.
In a sense. What's even more interesting is that some studies directly compare fasting to bariatric surgery. One study showed that a structured fasting program led to better results than surgery for both weight loss and blood sugar control in diabetics.
Fasting outperforming surgery, that's pretty remarkable.
It is, and it highlights the potential of dietary interventions. It's also common practice to have patients fast before bariatric surgery to reduce liver fat, which makes the surgery easier and safer.
So fasting is being used as a tool in the context of surgery as well.
Exactly. And while we're on the topic of bariatric surgery, it's important to be aware of potential complications. Gastric bypass, for example, has a long list of possible problems. Intolerance to certain foods, kidney stones, leaks from the surgical connections, nausea, vomiting, nutritional deficiencies, organ damage, narrowing of the digestive tract, ulcers, infections, bleeding, blood clots, bowel issues, a condition called dumping syndrome, dehydration, indigestion, gallstones, worsening GERD or dye, low blood sugar, and hernias. It's estimated that early complications occur in about 10% of cases and late complications in about 15%.
That's a sobering reminder that any surgical procedure carries risks.
Definitely. Now, with all this information, people naturally have many questions about IF, so let's address some of the most frequently asked ones.
Great idea. What about drinks during fasting? Can you have anything at all?
Yes, staying hydrated is important. Water, black coffee, unsweetened tea, and other non-caloric beverages are generally fine. The key is to avoid calories from sugar, sweeteners, or too much milk or cream. A tiny bit of milk or cream might be okay for some, but less is better. And black coffee can actually help suppress hunger.
Good to know. Another question is about skipping breakfast. We're always told it's the most important meal. Is it unhealthy to skip it with IF?
That's a common concern, but the idea that skipping breakfast is inherently bad doesn't really hold up. The problem is that people who habitually skip breakfast often have other unhealthy habits. If you eat healthy during your eating windows, skipping breakfast with IF can be perfectly healthy.
That makes sense. What about supplements? Can you take them while fasting?
Generally, yes, you can. But fat-soluble vitamins like D, A, E, and K might be better absorbed with meals that contain some fat, so consider taking those during your eating window.
Okay, what about exercise? Can you work out while fasted?
Yes, it's safe for most people to exercise while fasted. Some even prefer to work out before their first meal. Some say it boosts fat burning. Some people also take branched-chain amino acids, or BCAAs, before a fasted workout, although the evidence for that is mixed.
So IF doesn't have to interfere with exercise. Now, a big concern for many is muscle loss. Will IF cause you to lose muscle?
It's true that any weight loss method can potentially lead to some muscle loss if not done properly. That's why strength training and enough protein intake are essential. But interestingly, some research suggests IF might cause less muscle loss than traditional calorie restriction.
That's reassuring. What about the fear that IF will slow down your metabolism?
Short-term fasts, the kind usually used in IF, don't generally slow down metabolism. In fact, some studies show they might even temporarily boost it. Very long fasts, like 3 days or more, might suppress metabolism, but that's not typical for IF.
Okay, so no metabolic slowdown with typical IF. Last question in this section. Is IF safe for kids?
Generally not recommended. Kids are still growing and need consistent nutrients. Restricting their eating without medical supervision could be harmful.
Makes sense. Let's move on to safety considerations and limitations.
A 2014 review showed that IF improves things like blood pressure, insulin sensitivity, inflammation, and cellular stress responses. It also suggested potential for reducing chronic disease and cancer risk. However, it's important to acknowledge the limitations of the research. IF hasn't been extensively studied in children, the elderly, or underweight individuals. It could be harmful for those groups.
So they should be extra careful, maybe avoid IF altogether.
Definitely. Also, fasts longer than 24 hours should ideally be done under medical supervision because of the potential effects on the digestive system and circadian rhythm. And it's worth noting that IF alone might not be enough for significant health improvements beyond obesity if it's not combined with calorie restriction and a healthy diet like the Mediterranean diet.
It's not a magic bullet. It works best as part of a bigger picture.
Exactly. And importantly, IF isn't for everyone. Some people should be especially careful or avoid it altogether.
Who should be cautious?
People who are underweight or have a history of eating disorders should absolutely consult a doctor before even considering IF. It can be very harmful for them.
Very important warning. What about specific considerations for women?
There's some evidence suggesting IF might not be as beneficial for women as for men. For example, one study showed it improved insulin sensitivity in men, but worsened blood sugar control in women.
Interesting. So there might be a difference in how men and women respond?
Right. Also, some animal studies in rats have shown potential negative effects on female reproductive health, like emaciation, masculinization, fertility problems, and irregular periods.
Concerning.
There are also anecdotal reports from women whose periods stopped when they started IS and then returned when they stopped. So it seems IF could potentially affect female hormones and reproduction.
So women need to be more cautious with IF.
Yes, more research is needed. In the meantime, women should start slowly, Monitor their bodies closely and stop if they have problems like amenorrhea or fertility issues. And of course, pregnant or breastfeeding women should avoid IF altogether.
What about general side effects? What can people expect?
Hunger is the most common side effect, especially at the beginning. Some people might also feel weak, tired, or have trouble concentrating as their body adjusts. But these are usually temporary.
A bit of an adjustment period.
Exactly. And again, if you have any medical conditions, talk to your doctor before trying IF, especially if you have diabetes, blood sugar issues, low blood pressure, take medication, are underweight, have a history of eating disorders, or if you're a woman trying to conceive, have amenorrhea, are pregnant, or breastfeeding. But for healthy individuals, IF has a good safety profile.
That's good to know. Let's summarize what we've learned in our deep dive into IF.
We started by talking about metabolic syndrome being a huge problem with no easy solutions from conventional medicine. But things like bariatric surgery, fasting, and very low-carb diets have shown more promising results.
And we learned that our bodies can handle going without food for a day or two without harm.
Right. Humans have evolved to survive periods of food scarcity. IF offers two main types of benefits, those related to fasting itself and broader health benefits.
Let's break those down. What are the fasting benefits?
Well, the rules are pretty straightforward. You don't necessarily have to be super strict. There's less emphasis on weighing and measuring food. The dramatic calorie cuts on fasting days might make it harder for your metabolism to slow down. It also can simplify your life, less time cooking and eating, potentially cheaper, and you eliminate entire meals rather than just trying to eat less calorie-dense versions of your usual foods.
Those are really practical advantages.
Absolutely. Now, for the health benefits, we have a pretty long list. It can promote fat burning for weight management, increase growth hormone levels, normalize insulin and leptin sensitivity, normalize ghrelin levels, lower triglycerides, improve disease biomarkers, reduce inflammation and free radical damage, and even potentially help preserve memory and learning.
It sounds like IF triggers a cascade of positive changes throughout the body.
Exactly. And as we said, it can simplify healthy living by reducing the need to constantly plan, cook, and clean up after meals. It's free, saves time, can be done anywhere, and effectively lowers insulin and body weight.
So after all this, the question is, should you try IF?
It depends. It is not for everyone. It's just one strategy for improving health. The most important things are still eating real food, exercising, and sleeping enough. The best diet is one you can stick with. If it's great for some, not for others, the only way to know is to try it. If it feels good and you can sustain it, it can be a powerful tool for weight loss and health improvement.
So it's about finding what works for you individually.
Precisely. If someone wants to give EV a try, how would you suggest they start?
I'd say start with something manageable, like the 168 method. If that feels good, you can try more advanced fasts, like 24-hour fasts once or twice a week, or the 5.2 diet. You don't need a complicated plan to get started.
Good advice. Experiment and find what fits your schedule and preferences.
And any tips for making it easier?
A few things. Make healthy food choices during your eating windows. Be patient. It takes time to adjust. Exercise can help. Find the optimal fasting window for your routine. Don't jump into long fasts right away. Don't overdo it. Daily fasting can be problematic. Eat enough protein. Think of it as a lifestyle, not a quick fix. And remember, it's not for everyone, especially people with eating disorders or very fast metabolisms.
Excellent advice. So in this deep dive, we've explored the different methods of intermittent fasting, how it works on a biological level, its benefits for weight loss and health, and important safety considerations.
It's a flexible eating pattern that can influence key hormones, trigger cellular repair, and be a powerful tool for weight loss and health improvement.
But it's not for everyone, and it's crucial to listen to your body and consult a doctor if you have any health concerns.
Absolutely. So as you think about everything we've discussed, here's a final question for you. What small change could you try in your own eating schedule to potentially tap into some of these benefits? We encourage you to explore this further and find what works best for you.
Thanks for joining us for this deep dive. Until next time, take care.